right, so next we're talking about the mean of a discrete random variable, which is also called the expected value. So the mean or the expected value is the long run average over many repetitions of the same chance process. So again, that's kind of been the theme, right? That, probability is what happens in the long run, right? So again, that's why this long run average, many repetitions, okay? So suppose x is a discrete random variable with this distribution. To find the mean or the expected value, you're going to multiply each of the values of x by its probability. And here is the formula. So this guy is pronounced mu. So mu sub x equals, and now this ex is expected value of x, is the first value times its probability plus the second value times its probability, and so on. Okay. Again, you can ignore this notation here. This is just big boy and girl sigma notation if you take high level math, but it doesn't really matter. Okay. So let's see what we can do with this formula. Okay, so it says earlier we defined the random variable x to be the Apgar score of a randomly selected baby 1 minute after birth. The table gives the probability distribution for x1. It's again, calculate and interpret the expected value of x. So we're going to calculate it and we're going to interpret it. And again, when it says expected value, all that means is the mean. Well, if we look at this table here, right, where is most of the probability? This is a very low, 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 low. And then do you see how it gets really high right here around a score of 8 or 9? So we should expect that our expected value in this situation is going to be a score around an 8 or a 9. It could be a 7 because of all this tail, right? Remember, the mean is not resistant to skewness. So if you remember the shape from last problem, this is skewed to the left, so the mean could be skewed. So we could be looking at a value of 7, something around 7. But this is where we should expect our expected value or our average or our mean to be. So how are we going to find this? Well, to find mu sub x, we're going to take our first value of 0 and multiply it by its probability, plus its second value of 1 times its probability, and so on, until we do the very last one, which is 10 times its probability of 0.053. So I'm going to take a picture of this because that's hard for me to remember everything, and we're going to do it together, all right, in Desmos graphing calculator. Okay, so I got my picture. All right, let's go to that calculator. Okay, here's what I'm going to type out all at once, right? Big, so 0 times 0.001 plus 1 times 0.006 plus 2 times 0.007 plus 3 times 0.008 plus 4 times 0.012 plus 5 times 0.020 plus 6 times 0.038 plus 7 times 0.099 plus 8 times 0.319 plus 9 times 0.437 plus 10 times 0.053. And there, I got an average and expected value of 8.21. Okay, so if I come back to my Google Slides, so our mu sub x is 8.2, what did I get? 8.128. I don't know what I said, 8.21, 8.128, okay? And now here comes the interpretation. So again, this is an expected value, expected score. If we took a look at many, many repetitions, so we're going to say if many babies are randomly chosen, their average Apgar score 1 minute after birth will be about 8.128. If there were units, I would put the units somewhere, but they're not. So this is it. Okay. And again, as we said, it was going to be somewhere around here, closer to 8, probably because of all this skewness here with the 7s and below. Okay. But there we go. Now, I do want to show you how we can use the stats applet, okay? So there's a new stats applet called the probability stats applet in our group of applets, okay? So we'll go to the same place, the stats applet, but we'll find the one that says probability. I invite you to do this with me, okay? So here, I'll go to these stats applets over here. Stats applets, and again, this probability one. So again, now you have to choose the correct type. So we're doing a discrete probability distribution, okay? I don't care about our variable name because I'm not graphing it. All I want to do is enter the values. So there are going to be 11 because 0 through 10. So there's going to be 11. So again, I'm doing double the work, right? I would do one or the other depending on what I asked. So 0.001, 1.006, 2.007, 3.008, 4.012. I'm just using tab to get through. 5.020, 6.038, 7.099, 8.319, 9.437, and 10.053. And if I begin analysis, it gives you the graph, which I don't really care for their graphs because they don't do a very good job of putting the values on there. You can see they didn't even label it. Now I wonder if if I said what APGAR score. Let me see what happens. Analysis. Yeah, see, they don't even put the labels on. Okay, but notice here, the mean. They give you the mean, 8.128. So this is another way to calculate the mean. And, I'm grading this on Edge Elastic. So again, I can't really tell if you use the formula or use the stats app, but so you can do what you want. Okay, for sure. All right. So that is finding the mean. Last objective coming is finding the standard deviation.